here you can see the website is hosted at magento.2 domain name, and this category page is open. What we are going to do is we are going to profile this listing page and see how we can improve the performance. Now, how do we access profiler? On the same domain, if I just add this particular um, query string, this will be available. Now you can see in the whole SPX control panel UI, first thing I have to do is enable the profiler. By default, you'll see that these are unchecked and this is set to disabled. We'll get to this in a minute. What you want to do is you want to come here and enable profiling. Start profiling as soon as your request starts, which is automatic start, and then don't sample all the functions that will be called, because it's not particularly useful in my experience and is more memory consuming for the browser. So what we want to do is sample at an interval of 1 ms. We'll get back to this in some time. Then max profiling depth should be unlimited, and we don't want to track anything else right now. So as soon as we profile a page, the URL will be visible here, down here. Right now you don't see anything. I'm just going to quickly enter in the full screen mode. Yeah. Now let's go back to our page and let's access this category 5.1 and let the page load. And you can see we are on category 5.1. Now let's go back to our SPX UI and let's refresh this page. Once the page is refreshed, you can see that magento.2 category 5-1.html is available here. The total wall time is 1.43 seconds, so this took 1.43 seconds, and we want to see how this can be optimized down to 200 to 300 milliseconds. Now to open this profile, all I have to do is click this, and as soon as I do that, SPX will load the profile. Now you can see the profile is loaded. Now what does this mean? How do we make sense of this whole data that is available to us? This is known as call graph. You can see it's called call graph because I can drag this and I can see that product list.html took 1.20 second, which is visible here. This is visible, and this is happening because of a lot of small calls where each call takes around 31 ms. Now our job is to figure out what are these small calls and how can we optimize this. Let's do that. Now